Electromagnetic radiation encompasses a broad range of wavelengths and frequencies, from astronomical proportions, 10 to the 8th meters, like Earth to Sun distances, down to tiny microscopic wavelengths, 10 to the minus 16th meters. The ranges have different names, basically historical names, describing the kinds of radiation in each band. So the long wavelengths, radio waves, microwaves slightly shorter in wavelength, still though in proportions we could resolve, a few meters to a few centimeters. Infrared radiation now down below our range of resolving it, and visible, ultraviolet radiation, X-rays, and gamma rays. All these flavors of radiation are emitted by the sun, so during solar events, the Earth is bathed by all these kinds of radiation, and there's other sources of these radiation. Obviously, we can make microwaves and radio waves, infrared waves, and visible waves. We have flashlights, we have microwave ovens, we have heaters, we have radios. So all those things we're able to produce electromagnetic radiation. The visible spectrum, in particular, in between the infrared and ultraviolet, we're going to look at a lot. These are the wavelengths that our eyes are sensitive to, from 400 to 700 nanometers approximately. So blue, green, yellow, orange, and red light we can detect, and these wavelengths stimulate our eyes, and those signals travel to our brain, and we perceive different colors. The combination of all those colors altogether would give us white light. So from blue to red completely all at once, you would perceive white light. But you can take white light and break it back down into its component colors. You can do that with putting obstacles in the way, putting a grating in the way of the light, so the light of different wavelengths interacts differently with that grating or those obstacles. So long wavelengths are diffracted differently than short wavelengths, and you can spread out the wavelengths in space. And we can actually do that. Diffraction gratings are cheap and easy to make. There's actually some in these glasses here. What I'm going to do is I'm going to take this white light source, I'm going to turn that on, and we'll put on these diffraction glasses, and we'll be able to see when we look at the light, it resolved into blue, green, orange, red, its component colors. So this is a beautiful example of the electromagnetic spectrum, white light being resolved into its component wavelengths by a diffraction grating. We'll be talking a lot about wavelengths and visible light during this course, so this experiment with a diffraction grating showing separation of wavelengths is very useful for our understanding of light.